So we were doing partial fractions, and in the last session, we talked about the three different forms of partial fractions that we've got. First of all, we could have non-repeated linear factors, we could have repeated linear factors, or we could have quadratic factors, right? These were the three possibilities that we could have. All right. We discussed this method earlier, how to find partial fractions. We used to break the fraction down using the form that corresponds to the fraction that we get. And then we use this method where we input some specific values of x to find the unknowns by eliminating some of the other unknowns, right? So that's what we did. We did a couple of examples in this. We were done with one example in which we had non-repeated linear factors like this. We also did one example in the last session where we had repeated linear factors. So this was an example in that. Now today we want to do one last concept that we have in partial fractions. And
अच्छा बैठने नहीं होगा वो अच्छे खासे मारो.
can everyone please mute themselves? All right. Okay, so now today what we want to do is we want to do one last concept that we have left in partial fractions, and that is what happens when we have improper fractions, right? So you might have seen in the worksheet sometimes the standard form that they give is slightly different. So for instance, you might have seen this question number 11. In this, you also have this constant added on the side, right? So we'll talk about this today. But before we do this, we want to do one example on quadratic factors as well. Okay, because we haven't done one on that yet. So let's do one example on that, and then we do improper partial fractions. Let's start with this. In this example, we've got one linear factor and the other is a quadratic factor. Okay, so this is a non-repeated linear factor. We could say this is a over 3 minus x for the non-repeated factor. And then for the quadratic factor, we need a linear expression in the numerator, bx plus c, that divided by 1 plus x squared. Okay, so you need to remember that these forms, just writing this much, this gets you 1 mark, okay, without even calculating any constant. So that's the first step. You write down the form that corresponds to this fraction. Now, what you do is you multiply the denominator on the left side with each fraction on the right side. Okay, you take it to the right side there. Now, what are you going to be left with when you do this? 9 minus 7x plus 8x squared, that is identical to a times, when this thing gets multiplied on the other side, 3 minus x and 3 minus x, they're going to get cancelled. And you're going to be left with a into 1 plus x squared. And then you have bx plus c. When this thing multiplies with this, 1 plus x squared and 1 plus x squared are going to get cancelled. And you're going to be left with 3 minus x. Please make sure that you use brackets with this bx plus c. This whole thing is in brackets. All of this is being multiplied with 3 minus x. Okay, if you don't use brackets here and just write it like this, bx plus c into this, that's wrong, because that means only c is multiplying and that's not what is happening. Okay, so you should be using brackets here properly. So it's bx plus c brackets multiplied by 3 minus x. Okay, so this is what we get. Now what we need to do is we need to look for some values of x that can make some brackets 0 and eliminate them. Okay, now let's start with this. Can we make this 0? 1 plus x squared equal to 0? Let's try doing that. We get x squared equals minus 1, and that's not possible. So we don't have any value of x here, right? So we can't make this bracket 0. This is not possible. So we can't do anything here. So we have to skip this. Let's look at the other bracket that we've got. This is the only other bracket that we have out of these two. 3 minus x. What do we do with this? Put this equal to 0. What value of x do we get from this? X equals 3. So that could be our starting point. Let's first input x equals 3 and see what happens when we do that. On the left side, we've got 9 minus 7 into 3 plus 8 into 3 squared. Now, wherever we have 3 minus x on the right side, that term is going to become 0. So this whole thing, this is going to become 0, because when we input x equals 3, this bracket becomes 0, and that makes this whole thing 0. We're just left with this. That's a into 1 plus 3 squared. And now we can simplify this and see what this gives us. 9 plus 1, that's 10. 10 times a, this equals 9 minus 21 plus 8 into 3 square. What do we get from this? What do we get on the left side? Anyone? Okay, I think this should be around 60, right? Yeah. So this turns out to be 60 on the left side. So a equals 6. The value of a that we get from this is going to be 6. Okay, so we find the value of one of those unknowns. We have a now. Okay, let's look at the chart box there. Let's see that there. Okay, all right. So we've got the value of a that equals 6. Now, what else can we make 0? Do we have any other brackets left? There's no other bracket left. So what do we do now? Once this when this happens, remember what we said? We could input just any other value of x. And generally, we start from x equals 0 if that hasn't already been used. If not x equals 0, we could try x equals 1. In this case, if we input x equals 0, what happens? This thing is going to become 0, right? When we input x equals 0, b times 0, that is going to be 0, right? So b is going to get eliminated. We already know the value of a now, and we can find the value of c in that case. So that could be the next value that we input here. We input x equals 0, all right? And along with that, we input whatever value we have found earlier. So we have found that the value of a is 6. So we can also input that along with this. Let's input these values. 9 minus 0 plus 0 on the left side. On the right side, we've got 6. That's the value of a into 1 plus 0. Plus b times 0, that's a 0. Plus c into 3 minus 0. Now we can simplify this. On the left, we've got 9. On the right, we have 6 plus 3 times c. 3c equals 3, and the value of c turns out to be 1. Okay, so we found c equals 1 from this as well. All right. So we have a now, and we've got c now. What do we do at this point? We could choose another value of x, any value of x. And another easy value of x that we could input could be 1. That makes our calculations pretty straightforward as well. Let's do that now. We input x equals 1 along with the values that we have found already. A equals 6 and c equals 1. Okay, because we can't make any bracket 0 anymore. So now we input values like this. X equals 0, x equals 1, x equals 2. and we can evaluate the rest of the guns. Now, what do we have on the left side? 9 minus 7 into 1 plus 8 into 1 squared, right? On the right side, we've got 6 times 1 plus 1 squared, all right? Plus bx plus c. Plus b is unknown. We need to find that. B into 1, that's just b. Plus c, c is 1. Into 3 minus x. That's 3 minus 1. And now we can solve this. 17 minus 7, that is 10. We've got 10 on the left side. On the right side, we've got 6 into 2, which is 12. Plus b plus 1 into 2, that's 2b plus 2. All right, so this gives us minus 4 equals 2b, and the value of b turns out to be minus 2. We've got the values of a, b, and c. We can write down the partial fractions now. The partial fractions that we've got turn out to be this. We just input values of a, b, and c here. Value of a was 6. So we've got 6 here. B is minus 2. So that's minus 2x plus c plus 1. And that is our final answer. Okay. These are the partial fractions that we were looking for. Any problem with this? Okay. This is what we do when we have quadratic factors. We start with bx plus c for that quadratic factor, and then the rest of the process remains exactly the same. In this, you need to input some extra values of x because you'll not have many brackets that you can make 0 every time. So you can once you run out of brackets, you input x equals 0, you input x equals 1, and sometimes x equals 2 if you need to. All right. This is how this process works. Now let's start with what happens when you have improper fractions. Improper fractions. Now, first of all, we need to understand what improper fractions mean in when you have polynomials. In polynomials, what exactly do they mean? Remember what it used to be for numbers? What used to be called proper fractions? What were improper fractions? If you had, for instance, 3 over 5, this would be called a proper fraction, right? Why? Because in this case, your numerator is less than the denominator. This is a proper fraction. Okay. But on the other hand, if you had something like this, if you had 7 over 4, this is an improper fraction. This is an improper fraction. Why? Because in this case, your denominator is bigger than the numerator, and denominator is less than the numerator, or you can say numerator is greater than the denominator. So this is an improper fraction. Right? That is how it used to be for numbers. Now, when we talk about polynomials, we actually look at the degree of the polynomial to decide whether that fraction is uh, is a proper fraction or an improper fraction. Okay. So first of all, what is the degree of a polynomial? Let me write that down in case you've forgotten. Degree of a polynomial. degree is basically the highest power of x, or whatever the variable is, in this simplified form. So you might have factorized form given, but degree would be the highest power that you get after you simplify everything, after you do all the multiplication and simplify everything. The highest power of x that you get in that case is going to be the degree of that polynomial. Now, let's take some examples. So remember this, degree is what? It's the highest power, but you're not just going to look at it as it is. For instance, if you have x plus 2 into x squared minus 2, the degree of this polynomial is actually 3. It's not 2. Why 3? Because when x squared gets multiplied with x, you get x cubed from that. So if you were to simplify this expression, x cubed would be the highest power. So the degree of this polynomial would be 3 in this case. So we're looking at the highest power in simplified form. Okay, that's what degree is. Now, degree is going to be used to figure out whether a fraction is a proper fraction or an improper fraction. Okay. Now, if you have, for instance, a fraction that looks like this, 2x plus 1 divided by x squared minus 2x plus 1. If you had an expression like this, look at the degree of the numerator. What's the degree of the numerator? What's the highest power in the numerator? It's 1. Degree of the denominator, it's 2. So the numerator is smaller than the denominator. The degree of the numerator is less than the degree of the denominator. This is a proper fraction. So for polynomials, we look at the degree of the polynomial to figure out whether it's a proper fraction or an improper fraction. Similarly, if you had something like this, 2x squared minus 3 divided by plus 2. What about this? If you look at the degree of the numerator is 2 and degree of the denominator is 1. This is an improper fraction because the numerator is bigger than the denominator. All right. What if you had something like this? 4x squared minus 2x plus 1 divided by x squared plus 3x minus 1. What about this now? In this case, you've got equal degree in the numerator and the denominator. So it's 2 in the numerator, 2 in the denominator. Remember when we used to have simple numbers, this would actually turn out to be an integer. So if you were dividing 3 over 3, that would just be 1. Okay, so it will always turn out to be 1 if the number was exactly the same. But for polynomials, it's only the degree that is same. The actual expression is different. So it does not simplify to 1. But the degree is the same for the numerator and for the denominator. When this happens, when the degrees are the same, this is also classified as an improper fraction. Okay. So a proper fraction would only be when the numerator's degree is less than the denominator. Otherwise, it's an improper fraction. Okay, so this is also improper if the degree of the numerator and denominator are same. All right. So let me simplify this now. When do you have a proper fraction? A proper fraction is going to be when the degree of numerator is less than the degree of the denominator. All right. This is the condition that we've got for proper fractions. What about improper fractions? Improper fractions would be fractions in which degree of the numerator is going to be either equal to or greater than the denominator. So for improper fractions, it would be either greater than or equal to. Both of them will classify as improper. All right. But now, when you're looking at partial fractions, there's actually a limitation in your syllabus. You will not be dealing with all different types of improper fractions. There's only a specific type that you will get in partial fractions, and that will be when the degree is actually equal. The greater than case is not in your syllabus as far as partial fractions are concerned. Okay. It'll either be a proper fraction, it'll either be a proper fraction like this, or it will be an improper fraction where the degree of the numerator and the denominator, they're both equal. It's going to be one of these two cases. Okay. You won't have the case where the degree of the numerator is greater than the denominator in partial fractions. You will get those fractions, but that will be when you have to divide the polynomial, divide the numerator by the denominator. That will involve the use of long division and stuff, right? But in partial fractions, you will only have fractions where the degree of the numerator and the denominator are equal. Okay, that will be the only case that you would have to deal with. For instance, you could have something like this. You could have a fraction that has that is 3x squared, or let's say 3x cubed, minus 4x plus 1, and in the denominator you've got x plus 1 whole squared into 2x minus 1. Now think about this. What's the degree of this polynomial? The highest power of the numerator is 3. What about the denominator? If you were to simplify this expression, this expression is going to give you x squared as the highest power. You've got x here. When they multiply, you're going to have x cubed there. So in both numerator and denominator, the highest power in simplified form is 3 in this case. So this is an improper fraction. All right, that will be an improper fraction. So you think about the highest power in simplified form. So this could be one case for which you might have to find the partial fractions. Okay. Now the problem is, how do we figure out what the partial fractions are going to be for this? What do we do when we have improper fractions? Okay. That is what we are going to look at. And we're going to look at with the help of an example, but we're actually running out of time. So we'll actually do this in our tomorrow's class. I need to end this a bit early today. Let me just copy this question and show how this is an improper fraction. And then we'll see how to deal with this in our next class, inshallah. Let me just copy this here. This is question number 16 from the worksheet. So for the next class, you should keep in mind what improper fractions are. And then we will learn what to do with them using this example. This whole explanation is going to be slightly long. So that's why I just want to do it in the next class then, because otherwise we'll need to take about 20 more minutes. And I need to end this early today. Let's first figure out whether it's a proper fraction or an improper fraction. Look at the numerator. In the numerator, the highest power is 2. In the denominator, what about the highest power? X into 2x. That gives you x squared. So the highest power in the denominator is also 2. So what type of fraction is this? This is an improper fraction. Now, all of these different types that we have done earlier, these forms that we have done earlier, they were actually relevant for proper fractions. For improper fractions, we're going to have a slight variation in these forms, and we're going to talk about that in the next class, inshallah. We'll learn that using this particular example. Basically, what happens is in all of these forms, when you have improper fractions, you end up having to add another constant like this. That's the only difference, actually. You could add that constant at the end or at the start. That doesn't make any difference, but you end up having another constant. Okay. Then there's a shortcut of how to find this constant. We'll do that in the next class. Uh, and then we will be done with partial fractions. Okay, so we'll spend some time on doing some more practice questions after that. Also, the ones where we have both binomial and partial fractions. But that's for the next class then, inshallah.